everyone! So we're going to do lesson 2 of this Trig Identities unit. So we're finally going to be able to use some of the formulas given to you on your formula sheet. So here's a little snippet of what we're going to be using, and you'll be given this on the exam. So here, this is basically just learning how to plug in the values they give you and how to rearrange it in an equation. You'll see what I mean as we go through the lesson. So here, write each expression as a single trigonometric function and determine the exact value. So what you should notice here is that despite this, they're saying sine and cos, we see the numbers 47 and 17 repeating. So from left to right, we're just going to label this by A's and B's. So 47s are going to be represented by A's, and 17 is represented by B's. So AB, AB. So now, if you were to look at this equation, and let's just ignore the values, the numeric values for now, and let's just write this as sine A cos B minus cos A sine B. What equation here from the top matches this? So as you're looking, you should notice that the second equation matches it. So here, sine bracket A minus B is equal to sine A cos B minus cos A sine B. So those exactly match. That means if we were to plug this into the equation, this is the same thing as sine A minus B. So that means here we could simplify this by plugging in sine A minus B, so A is 47, minus B, which is 17. So now, I'm just going to move this to the side. We're just going to simplify this further. So here we see 47 minus 17 is going to be 30. So we have sine 30 degrees, and then sine 30 based off of your special triangle, it's going to be 1 over 2. And that would be your answer. So here, we're going to do the same thing, but now it's for letter B. Cos squared pi over 3 minus sine squared pi over 3. So you should look at the argument, so the values inside the bracket, and check if they're different. If they're not different, you're just going to label them both as A. So here, this is the same thing as having cos squared A minus sine squared A. And now, when we look at our equation, what does this equal to? And you should notice that this is equal to cos 2A over there. Here, that means cos 2A. So if we were to rewrite this, it's going to be cos 2 times the A value. And your A value here is pi over 3. So when we simplify this, it's going to be cos 2 pi over 3. And cos 2 pi over 3, when you do your special triangles and your cast rule, it's going to be negative 1 over root 2. So here, just a little review, 2 pi over 3 lands in quadrant 2, and then based off cast, cos is negative there. Now, letter C. This is probably one of the more harder ones that trick a lot of students, but once you see this little tip, it'll help you a lot. So we have 10 sine pi over 8 times cos pi over 8. So these are the same values, so we're just going to label them A and A. So here we have, we're going to ignore the 10 for now, but we have sine A cos A. So sine A cos A is the same thing, therefore is most similar to the equation 2 sine A cos A. But in order to have, hold on, let me rewrite this. But in order for this sentence to be true, there has to be a 2 at the front here, right? Because here, again, sine 2A equals 2 sine A cos A. So you need to have a 2 at the front here. But we're given a 10. And that doesn't equal the same thing, right? But are we able to break up the 10 so that way we're given a 2? We are. So here, if you were to break up this equation, this is the same thing as having 5 times 2 sine pi over 8 times cos pi over 8. So again, even though we didn't explicitly be given a 2, we could rearrange that first coefficient into 5 times 2. And we're allowed to do that because this whole thing is being multiplied by each other. So if we were to simplify this, we have 5 times sine 2a, so 2 times pi over 8, which is the same thing as 5 times sine pi over 4, and that's the same thing as 1 square root 2, 5 times 1 over root 2, which simplifies to 5 over root 2. And that would be your answer. So again, even though we're given a 10 here, and there's no 10s in this formula sheet, you just rearrange it, or not rearrange, but break it up so that way you fit something. Now we're on to example 2. So determine the exact value of the following. So here, we have cos 11 pi over 12. So we haven't seen any fraction where our denominator is 12 yet, nor we ever will, except for these questions. But whenever you're given something like this where your denominator of your argument isn't a 1, 2, 3, 4, or 6, like the common ones we're used to, that means you need to break it up into an equation. So here, you're going to break it up by having your fraction into 2 other fractions. And you'll see what I mean in a bit. So here, whenever you're given a positive fraction, there's going to be a plus sign separating the two. So you're going to break up the 11 pi over 12 into 2 separate fractions. So in order to know what your numerator should be, you're going to break it up into pairs. So here 11 can be broken up into 1, 10, 2, 9, and 3, 8. To know which pair you pick is you should pick a pair where both the values allows you to reduce your fraction into a fraction that you're used to working with. So whether that's the pi over 2, pi over 3, pi over 4, pi over 6, and so on. So if we had 1 pi over 12, that's not something we could reduce or we're used to. We know that first one isn't working. If we pick 2 pi over 12 and 9 pi over 12, we can reduce these numbers. So we know this is the pairing we're going to use. So here, 2 pi over 12 is the same thing as pi over 6 plus 3 pi over 4. And now we're going to pause here and look at our argument. Are these two values the same? They're not. So we're going to label them A and B. So right now, we have cos bracket A plus B. And if you go back one page, we're going to look at that formula. So cos A plus B is the same thing as cos A times cos B minus sine A times sine B. And we're just going to rewrite that. So here, cos A cos B minus sine A sine B. And we're just going to rearrange all of these. Not rearrange, we're going to substitute our values for a and b. So I'm just going to move this to the side. Oops. Actually, I'm just going to delete it. You could keep it on the side of your page, but I'm just going to erase it just to save room. So here, we just plug it in. So it's going to be cos pi over 6 times cos 3 pi over 4 minus sine pi over 6 times sine 3 pi over 4. And again, we're just taking it from this equation. So we're just going to evaluate this into the exact values. So this is a question you guys saw in the other trig unit. So using your cast rule and the special triangles, it's going to be square root 3 over 2 times square root 2 over 2 minus 1 over 2 and square root 2 over 2. For this specific question, or these types of questions, you have square root 2 over 2. This is the same thing as 1 over root 2, but I just always recommend students to rationalize it just so that way it's easier when you combine your denominators later. So in order to rationalize, just a little review, is you're going to multiply your numerator and denominator by the square roots. So here, the square roots cancel. So 1 times square root 2 is square root 2, and your denominator is just going to be 2. That's how you rationalize. So now, if you simplify this further, square root 3 times negative square root 2 is negative square root 6, and then 2 times 2 is 4. Now on the right side, 1 times square root 2 is square root 2, and then 2 times 2 is 4. And if we were to combine everything into one fraction, it's just going to be negative square root 6 minus square root 2 over 4. And then that would be your answer. So now we're going to do cos. So here, cos 19 pi over 12. So we have to break up our fraction again, and because it's a positive fraction, it's going to be broken up by positive fractions. So cos 19 pi over 12 is the same thing as something over 12 plus something over 12. And when you're thinking about pairings, this could be 18 and 1. That's not going to work. And as you go through your list, you're going to realize 9 pi and 10 pi is going to work. So here, if we were to reduce this, it's going to be cos 3 pi over 4 plus 5 pi over 6. And just as a little tip, whenever you have your denominators at 12, usually you're going to get some form, you're usually going to get 3 pi over 4. It's just a common thing that's going to happen all the time for most questions, but that's like a safe go-to to go for your first pairings, just to look for something. I don't know, just like a little tip I noticed. But anyway, so here, it's going to be the exact same formula as letter A, where we have the cos A, cos B. So now it's going to be cos 3 pi over 4, cos 5 pi over 6, minus sine 3 pi over 4, sine 5 pi over 6 again. Exact same question or formula as this one, we're just replacing the numbers, and they all came from the formula sheet here. This one. So if you were to break each of these up into brackets and doing your cast and triangle rules, you're going to get negative square root 2 over 2 negative square root 3 over 2. And then you're going to get square root 2 over 2. And then 1 over 2. And then here, you're going to get positive square root 6 because the negatives cancel over 4 minus square root 2 over 4. And then when you put everything together, because it's the same denominator, it's going to be positive square root 6 over minus square root 2 all over 4. And that's it for the example 2. So we have one more question here. And here, it's going to be cosecant. And it's a negative fraction. So when you have a negative fraction, the only thing different here is when you break up your argument, it's going to have a negative sign in the middle. It's not going to be a plus sign. So, similar to the trig unit, we're not going to actually work with cosecant quite yet. What we're instead going to do is we're going to change this to the reciprocal function. So the reciprocal function for this is going to be sine negative 7 pi over 12. So sine negative 7 pi over 12, if we were to break this up, it's going to be sine something over 12 minus something over 12. And we want to get a pairing that will give us negative 7. So when you go through your list, it's going to, again, as a little tip, whenever you see your denominator is 12, you should reduce it to something over 4. So it's going to be 9 pi over 12, so 3 pi over 4. And if the 9 is going to be here, that means you're going to have a 2 here, because 2 minus 9 is negative 7. But if you want, you could just go through the listing of pairings again. Choosing 9 pi over 12 is just my little tip. So here, this is a and b. So now we have sine a minus b. So we're going to look at our equations again. So sine a minus b is going to be this formula. So here, before we use the formula, we're just going to reduce. So sine pi over 6 minus 3 pi over 4. And then that's going to be the same thing as sine pi over 6 cos pi over 4 minus cos pi over 6 sine 3 pi over 4. And if I'm going too fast, I'm just going to write in the bottom here. This came from sine a cos b minus cos a sine b. So we're just substituting it in. And then now, if we were to rewrite this, or not rewrite this, if we were to change this into exact values, we're going to have bracket, bracket. It's going to be 1 over 2, negative square root 2 over 2, square root 3 over 2, square root 2 over 2. And then when we put everything together, you're going to have negative square root 2 over 4 minus square root 6 over 4. And then it's going to be negative square root 2 minus square root 6 over 4. And a lot of students tend to leave this as their answer, but you have to remember, our question is cosecant, right? We did sine, so that means we need to flip this fraction. So your final answer, and you're going to write this at the top here, it's going to be 4 over negative root 2 minus square root 6. That's going to be your answer. Do not write it here. Like, if you wrote it here, that's wrong. Because you're saying, oh, those two things are the same. They're not. So you have to put your final answer at the top. So here, example 3. If angle A and angle B are both in quadrant 2, sine A equals 4 over 5 and cos B equals negative 12 over 13. Determine the exact value of the following. So here, before we start, I'm just going to look at the equation cos A minus B. So cos A minus B is the same thing as cos A cos B minus or plus sine A sine B. Now we need to figure out what's the exact values we plug in. So they give us sine A and cos B, but if you look at our question, we start off with cos A. They didn't actually tell us what cos A is. So whenever you're given this type of questions, and you'll probably see this honestly on an assessment, is you should draw it out and just figure out your triangles. So what I mean by this is, if I were to draw out my quadrants, quadrant 2 is in top left corner, right? So here, sine is related to O over H, and then cos is A over H. So for sine, our opposite value is going to be 4, so it's a positive 4, and then our hypotenuse is 5. So if you need to figure out what your adjacent is here, how can you do that? Well, you're going to do before I even get to that part, a lot of students like to write a squared plus b squared equals c squared, which is the correct formula, but because we're working with a's and b's, and I think this is honestly silly, but it's like a rule, you're not going to write a's, b's, and c's. Instead, you're going to write xyz or xyr, where r is radius, instead, because you don't want to mix up the variables. It's like a rule, I don't know. So here, we have x squared plus y squared equals r squared, and r squared being our hypotenuse. So here, if you were to plug in 4 squared plus y squared equals 5 squared, you will eventually find that this is going to be the value of negative 3. And here, just take a second and think, does that logically make sense? So if we were to look at this triangle here, right, this height here is a positive 4. Does that make sense? It does, because if you think of regular graphing, if it goes upwards from the x-axis, it should be a positive number, right? Now, this negative 3, does it make sense that this is negative? It does, because if you go on the left side of the graph, you're going towards the negative x values. So we knew we drew it right. Now for your other triangle, so this is triangle A. Now for another triangle here, for triangle B, it's in the same quadrant, and it's going to be the exact same setup, but now here it says our adjacent is going to be negative 12, our hypotenuse is 13. What is the opposite value? The opposite value, when you do some of the calculations, it's going to be 5. And it's going to be positive because, again, if you go upwards from the x-axis, it's a positive value. So we figured it out. So here, we're just going to plug in all our values. So here, cos A. Looking at cos A, cos is, for SOHCAHTOA, it's going to be adjacent over hypotenuse. Your adjacent is going to be negative 3 over 5. And cos B is negative 12 over 13 plus sine A, which is 4 over 5. And then sine B, it's going to be opposite over hypotenuse, so it's going to be 5 over 13. And then you're just going to simplify everything. So it's going to be 36 over 65 plus 20 over 65, which gives you 56 over 65. And that would be your final answer. Now for the last question, sine 2a. So it's using the exact same values as letter A and the question they gave us. Sine 2a is the same thing as 2 sine A cos A, given from the formula sheet. So 2 times sine A is 4 over 5, and then cos A is going to be negative 3 over 5. So your answer should be negative 24 over 25. So I'm going to write in red. Sometimes some students write sine 4 over 5. That is wrong. Sine A, like this whole term here, is equal to 4 over 5. So you're not writing sine bracket 4 over 5. But anyway, that's it for today's lesson. It's basically just going over finding what